Generative AI feels like magic, right up until the moment your local hardware runs out of memory and the system crashes. When you run an AI model directly on your desktop, what developers call bare metal, you are one conflicting Python library away from taking down your entire operating system. This approach makes testing new models incredibly risky. The industry's default solution to this instability is to rent managed graphics processing units, or GPUs, from massive cloud providers like AWS or Azure. This chart shows how fast those rental fees escalate. A single cloud GPU instance might cost $3 an hour, but leave that instance running 24/7 for a month of development, and the bill reaches over $2,000. A used workstation with a decent graphics card often pays for itself in less than a quarter. Beyond the price tag, renting means you lose visibility into how the model interacts with the operating system. And if you are working with proprietary data, sending it to a third-party server introduces privacy risks that many organizations can't accept. Developers are often stuck between the instability of a local desktop and the high cost of the cloud. A third option is an enterprise-grade hypervisor, a specialized operating system designed to manage virtual machines without the licensing fees. This is where that third option begins, an empty rack waiting for your own hardware. The software that makes this work is Proxmox. It's an open-source virtualization layer based on Debian Linux that installs directly onto your raw hardware. Proxmox takes the CPU, RAM, and storage of that single machine and carves them into isolated virtual machines. You get the contained sandboxes of a cloud provider, but running on your own equipment. If you are testing a new embedding system and break the environment with the wrong version of CUDA, the interface used for NVIDIA GPU computing, you don't have to rebuild the machine. You can roll back to a snapshot from 5 minutes earlier. This foundational layer addresses the fragility of bare metal setups. You can experiment, break things, and reset, all without a recurring subscription fee. To run local AI inference efficiently, handle the massive parallel processing required, and avoid system crashes, you absolutely need a dedicated graphics card. But by default, a virtual machine cannot see the physical graphics card. To bridge that gap, you use a technical maneuver called PCI passthrough. PCI passthrough instructs the motherboard to isolate the graphics card and hide it from the Proxmox host. Instead, it creates a direct tunnel straight into your specific AI virtual machine, giving the model near-native access to the hardware. Infrastructure control isn't just about owning the metal. It's about dictating exactly how your software accesses that hardware to maximize its processing power. Once you have a single node running, you can scale up by networking additional physical servers into the stack to create a cluster. This diagram shows how that cluster organizes an AI lab. The central Proxmox cluster hub manages the environment, delegating tasks across GPU servers. By using shared storage protocols like Ceph, you pool separate physical hard drives into one redundant network. This architecture lets you completely separate your concerns into isolated virtual machines, one for front-end web apps, one for your AI inference models, and one for monitoring resource consumption. If one of your physical servers suffers a hardware failure, Proxmox uses live migration. It instantly moves your active AI workload to a surviving server without interrupting the service. Clustering takes standard consumer hardware and creates a high-availability environment where your services stay online despite individual machine failures. We are seeing a shift in the tech industry where developers are reevaluating the default cloud-only mindset. Public clouds still serve a purpose. If you are training a massive foundational model or need to burst compute power for a few hours, renting is often the practical choice. But for daily testing, building embedded applications, or processing sensitive data, organizations are moving workloads back to local servers. Building a Proxmox cluster is a way to master the full AI stack. It forces you to understand exactly how models are served, how memory is allocated, and how the infrastructure functions from the ground up. When you rent a temporary cloud sandbox, your entire environment evaporates the moment you stop paying the bill. Local infrastructure gives you control over your tools. What you build stays on your network.